So I believe we have one more speaker who is online. He is Ranganathan Rajkumar, the Vice President, Automation and Advanced Analytics from TFS Next, based in Chennai, India. He will be speaking on what's next in big data analytics, automation, and AI, data center readiness. Over to you, Ranganathan. Thank you.
Thank you. Thank you, ARB. I hope all you folks can hear me. Please do let me know in chat. If not, you can't hear me. Okay, awesome. That's great. Thanks a lot. Let me just quickly share my screen and we'll get going. I know just after Adnan spoke, I'm just right next and like probably you guys are all very hungry. It's just going to be very short here actually. And let me put it on the presentation mode. Yeah, just to stick on the topic here, a very quick introduction about myself. I have over 19 years of experience in applied analytic distributed system, data warehouse, product management, software development. Come with a background experience building large-scale, reliable large-scale data pipelines and machine learning application. Done a lot of consulting and leadership experience in helping organizations to digitally transform and kind of lead the enterprise data strategy and program. And again, just you can see me here, I've been surfacing in many tech summits and other areas of this world. So quickly on today's agenda, I'm going to be like kind of maybe monotonous here. We're kind of talking the same thing many of those spoke about. A couple of slides just to talk about a quick thing on data center evolution. What are the challenges today? What are the future demands in the data center? And what are the top areas of development that are happening in this area of data technology and data center? And what are the convergence that we're seeing in the data center and the convergence of high performance computing and HPDA and a future of data center such. Now, so this is some pickup from a net app. So if you look at the data center itself, like, the evolution of it, it has come a long way, right? So from occupying an entire room or building and full of computers in the 90s, right? And the rise of the internet and client-server computing taking the center stage, right? So in the early 90s and the late 2000s, right? That's where the dot-com boom. This is the period where the data grew, right? As you could see, like exponentially growing up, right? And where organizations started storing huge amounts of data and, this business started growing, which demanded a need to evolutionize into a virtual technology, right? So this is where the rise of virtual data centers coming in the late 2000s and as such, and we could see 72% of organizations in the early 2000s, right, reported that the data centers were at least 25% virtualized, and we know probably today, as Adnan spoke about ODR and all the planning what you talked about, I'm pretty sure many organizations comes up with the requirement to virtualize to the first place, right? And of course, we're talking about from hyperscale, hypervisor, and all that. So a hybrid type revolution is the next way forward, started coming in, right? So I'm late on that, where we see 90% of the IT industry growth were driven by third-party platform technologies. The partnership just spoke, and we're talking about billions of dollars in money goes into the cloud computing as such. Now, that is not sufficient enough the way the data center evolved, right? And as you could see, it's all software driven now. Like the software driven data center is the norm today. And we are talking about a software driven data centers, like, predominant across the globe, right? And it's expected to grow beyond $6-7 billion, right? And of course, the important thing what we're looking is that, again, the phenomenal growth of the data itself, like 40 zettabytes of data is being created as we speak in this phenomenal year. So in a nutshell, that's the evolution of the data center itself, and including some of the things which my previous speakers talked about, the various different components, and I'm not going to get too deep into that. But that kind of brought into speaking about big data automation and analytics and the growth over the years that we have seen. If you look at the greatest challenge that we're seeing from the data center perspective is the processing power, right? Of course, there's this cloud and all that, but then again, speaking of holistically, from the data center perspective, the processing power that needs to actually also adopt in the way you are able to, cater to the need of the business, right? Based on the case and all that. Power management seems to be a very major concern when you're running a large cubical square kilometers of that, and of course the cooling requirements to come and make sure and all that. So we're in, a bit talking about processing power and power management in specific. We know the climate change is real, and one of the biggest loser or impactor when it comes to climate change is the availability and the cost of power as such, right? For example, Equinix company has been deploying through Bloom Energy and fuel cells and high cost energy, right? And making like in places like California and US and Massachusetts and New York, where the cost of the power is very high. In addition to that, the cost that prompts operators, as we're talking, to consider on-site power, right? So the time to market is also an issue here, where, for example, countries like Ireland, there is insufficient availability of power, right? So in some locations. And we know about the cooling requirements in terms of data centers where renewable energies, and there were a video that was shown earlier, so that I was showing, and those are some of the examples where they're trying to do liquid cooling, right? So liquid cooling are some of the examples where they are trying to tackle cooling requirements. And quickly talking about user experience is where we're looking at how the AI and data analytics, and just as one example of which we saw in terms of the energy, national energy and all that board and a dashboard which you looked at. So that's the kind of user experience they're talking about, the way how you can manage your infrastructure, manage the whole data center as such, right? And speaking about the processing power is where the rise of the AI and the GPUs and similar such ARM systems with the great current news, and most of you are technical are aware of the NVIDIA and the ARM, the way of approach and competing with Intel and all that, essentially means that we're talking about more power into the infrastructure, to the data center. Why? Why do we need that all? And it's because of the evolution that we are seeing in terms of the zettabytes of data that we're looking at, the way how data centers is hosted and applied today. So traditionally, it's been computing for data management, right? Storing for an enterprise digitizations, like, your CRMs to your Salesforce to your SAP applications and other low ends and so forth. And of course, it depends upon what kind of business you are in. Like we're also talking about many computing for data transfer, eventually data transfer networking. Already knows it well as a telco, like the amount of data that you transfer. I mean, I myself as an ex-Verizon employee, so I do know about such kind of media data that we're talking about. And in the age of YouTubes and Facebooks and others and advertisements and all that, we know about the data transfers and networking on the huge data center beats that is being taken. Again, computing for data center networking and contents that we are talking about, right? The new age micro old as such, essentially leading to something what we call as high performing computing, right? So computing for heavy algorithms, right? So applying and examples that we saw in terms of edge computings and data centers and all that, where your data center is moving towards and are today, where you're going to apply real-time analysis, right? Real-time data science, right? Be it maybe on cloud or in a hybrid environment, essentially demanding that for your data center to be ready to essentially cater to what is today a need for high performance computing within hybrid fashion. So that being said, if you look at the top development of the data center technologies, obviously talking about the zettabytes of data is the data storage, right? We do know that today the storage is getting more and more affordable, right? Rather than calling cheap. And you can see a lot of instances on the cloud provider, as well as I'm sure in some of your current data centers where these preferred storage solutions is SSDs, and of course other forms which are also coming up from the open source perspective too. And I just talked about from the form of virtualization, where the servers are being virtualized, and we know that we are at the age of software defined data center. And speaking of that, one of the things is like, as we know about many infrastructure as a service, platform as a service, one of the things is also going to be like data center of a service, right? Or data center network as a service. I'm sure a couple of those who spoke about probably Adnan spoke too. And of course, we know about hybrid cloud deployments. That's not going anywhere. That is where we're seeing some of the cloud providers hitching in, where they're providing their services in your on-premises environment, in your data center tools, such as like, AWS Anthos, or Azure Post, and Google Anthos, sorry, as like AWS Outpost, and all that are some of the example of the hybrid, where you're collaborating both your on-premise and as your crowd, or the kind of technologies. We are looking at more and more to happen, where where you can use your data center powers to actually do those distributed computing and your parallel processing in terms of your algorithms, and at the same time leveraging your cloud's power to be elastic and as such. And of course, that requires application to be closer to the data. This is where the edge computing comes into the picture. And we talked about the IoT examples, which we look at it from the National Center as well. One of the key things, again, when I talked about, and again, when there was a automation mentioned, is the fact is where is the dire need and important thing of looking at automating your data center, right? Which is the AI ops, where essentially providing all this, we saw those 25 freshers, right? So I think one of the key thing to add to that is the ability to actually give the user experience to them to actually manage this, and things like bringing the AI ops, making sure that you have an end-to-end visibility of data center, and applying AI into your data center, right? So as per Gartner, we're looking at 30% of your data centers in the future, is where AI will be and baked into it, right? And offered by the service providers too, and at the same time by the manufacturers too, as such. And one of the other important thing is like, bringing development in this data center technology is the robots, right? Where like hard swapping and swapping of certain things, we're going to look at real robots actually like, doing those jobs as such, and making sure they are smooth run. And again, as I said, many of the process, many of the redundant tasks and other things is part of the whole data center management and managed center services, where the RPA and intelligent automation coming into the picture are one of the top developments. Last but not the least, and of course, the intelligent monitoring of 5G is where, when we talk about the network, which we talked about earlier, I'm sure earlier, touched it to Adnan, is the bringing in the speed, delivering those through the 5G technology as such. So speaking about the data center convergence very quickly, is like we looked into the hybrid, the HCI, which we know, and CI, which we know in terms of that. So one of the next stage comes to, and I know because of this inflexibility, because of the the reason why the elasticity and other things, which are reliability and all those things which are provided by the cloud, which is why many of those, but we're seeing more and more power given to the users and others who build it, right? Where we're looking at the next stage in the data center convergence is the compressible disaggregated infrastructure, the CDI, also referred to the compressible infrastructure. This is CDI basically combines the best of the CI and the HCI, the combustible infrastructure, and the hybrid combustible infrastructure, and then it extends the offer to complete software-driven environment. So be it maybe your storage heavy for archiving, or it could be your compute heavy for your databases or AI and other analytics, or your general purpose for your BDI and other workloads, or for your administrative workloads, or it could be a disaggregated pool resources, right? Like in terms of compute, GPUs, memories, and so on and so forth as such. Now, this is a very core area of under development. There are no standards yet, and there's no definitions yet, but organizations such as HP's and Dell and other makers are trying to put in and bake it into there as they come along is the area. And speaking about the convergence, one of the biggest thing is the question is, hey, do I need a different environment, a different platform for my data and analytics and automation, and for my high performance computing, right? I mean, we just heard from the engineering association, national engineering associations, and RDOs and all this. I'm sure, and particularly the public sectors and and the defense and research and aviation, which we are looking at, or intensively high performance computing and using those traditional things. And of course, at the same time, they're applying deep learning and artificial intelligence to it. So maintaining two different environments is what we're looking at. But what we're seeing is an area of another things which we're looking at is a convergence of these two together, right? The HPC and HPDA. So you run your AI, data analytics, and advanced computing workload on one system, right? So if you take an example of a Dell system here, like, it has your, from the storage perspective, it has your scale out NAS, and it has this acceleration nodes for you, and it also has the manage and compute nodes plus your cluster switch all together. And if you look at the architectural perspective, and you have pretty much what you needed from the deep learning perspective, maybe a citizen data scientist as a data science platform. And from the processing power, which I talked about earlier, where the NVIDIA EGX and all that comes, and the end-to-end model deployment, right? As such, it comes through Kubeflow, and of course the cognitive sciences and all that through Clara AI and all that, addressing the data processing need, crunching massive amount of data, right? Which is always a challenge, right? From petabyte scale or data fragmentation, right? And ingestion and processing, right? And structured, semi-structured data, and as such, and of course, difficulty in maintaining merge, update, small files, right? And of course, the engineering experience altogether, right? So all baked in through Sparks and Jupyter, where collaboration is there given, addressing through NoSQL databases and all that, providing you the single source of truth, right? And a lack of unified experience, right? As such, along with the overall typical high performance computing that you do actually as well, and the management as well. So that's where the convergence of these two is looking at, where there's one system, one workload, and all that which you do. Finally, just to close this whole thing, where are we looking at this whole data center, right? What does the future looks like? From the location perspective, you're talking about today, we are in near fiber networks, or data centers are constructed in areas where the dense fiber networks are. We're looking at tomorrow is based on cool, stable climates, right? Climates of the Nordic region. We just saw that the whole thing was just dropped in the Nordic region, right? Allowing the data center to cool efficiently and save energy. And in future, we're looking at small pockets of this and offshore, right? Small offshore data centers add new capacity quickly. Like, it's like a Matrix movie or some other way you kind of build a building in no time, or maybe your a moving truck becomes a data center kind of, right? As such, at any time, anywhere. From the structure perspective, clouds and on-premises are going to be there. Hybrid cloud, the mix of a cloud and on-premise solution, which is widespread adoption. We know that that's what happened today. But tomorrow, we're really looking at, again, a smaller and larger, like, mega data center benefits from the economic scale, and the micro data centers, right, benefits from the latency and profitability as such. And we might have a future where there's no data center at all, because the data storage and computation resources are crowdsourced, right? And much like how we know about the blockchains and all that, we're looking at even some of the things, infrastructure's point of view in terms of storage or in terms of computation resources that you knew, or just like shared through P2P, right, through the device networks and all that. Similarly, the energy emission I just talked about from the challenges perspective, the cold and hot air related to the equipment, and specifically talking about the GPUs and all that, is where we're looking at as a next stage where it's not matured yet, the liquid AI cooling and all that, and AI assisted emergence, right? When I talked about the experience, when I talk about the AI ops and all that. And of course, reusability and is a serious factor what we're looking at from the environmental thing perspective, where reusing excess of heat, residual heats of recycles and redirected to communities is an important thing we're looking at. And from the renewable perspective, if we plugged in RECs is what we are looking at today. Many data centers are plugged into grid, balancing your dirty energy, RECs. But tomorrow we are looking at, again, renewables. Big tech buys renewables, right? So the FAMCA, like the Facebooks and Apple and all those, the FAMCA can afford to buy large amounts of REs for its centers, right? And whereas the RE farms and the data centers would work together tomorrow, like the future, right? The tech helps smaller buyers and producers connect, again, because there's also the fact it's going to the connecting the dots of the structure, right? Actually. And finally, the storage, because we're still exponentially growing data. And we just talked about example of just one area of Muscat. And I'm sure it's going to be exponential. We talk about the entire Oman, actually, I said. So we're talking about, I'm sure 90% of your storage devices shipped in price of the hard disk and all that, and which is going to be certainly more SSD based, right? As what we are looking at, more data centers are prevalent, and prices are certainly going to fall in the coming days in the future. But the future looks more with less, like innovations such as like, Hammer kind of, data storage. I think it has been, it came from a Seagate who actually invented it. And of course, the liquid state storage graded capacity are the ones we're looking at in the future as such. So that's what we're looking at, the future state of data center for, handling those need for challenges for processing power requirements, and of course for the experience, and of course saving the planet, I would say. That's pretty much for me, and thanks for this opportunity again, for the organizers. Over to you.
Thank you very much for that, Ranganathan, for explaining a little bit about the future of our data centers.